So I want to quickly go through the warm-up and some calculations that I may go through a little too quickly in class so people can go back and look at it. So our initial situation is we've got a cone here with a radius of 3, a height of I don't know, and a slant height of 4. Slant height is over here when you flatten out to the net. Radius is over here. So the question is, what's the height and then the volume? And then I got a secondary question here, is this is a right angle over here, which means there's actually two ways to calculate the area of this lateral, what I call the Pac-Man. And as a reminder, this doesn't always look like a Pac-Man. If it was a very tall cone, it would actually just look like a sector. It would not. It would be less than a semicircle. All right, so over here, volume is 1/3 area base times height. The area of the base is 9 pi because we've got a radius of 3, so 9 pi. The height is square root of 7 because I can use Pythagorean theorem. I've got the radius of 3 and the slant height of 4, so 16 minus 9 is 7, and so the height is square root of 7. So that's 3 square root 7 pi when I divide by my 3, and that's about 24.9 units squared. And then for the next part, over here, this is 3/4 of a circle. So one way I can do this is slant height is 4, so 3/4 of 16 pi is one way to do this. And then the other way is just to plug it into our formula here, which is pi times this radius over here times the 4. And either way, what I get is 12 pi. 3/4 of 16 pi is 12 pi. Pi times r times slant height is also 12 pi. And just as a reminder, usually they use like a cursive L to represent slant height. It's just a common way that it's often presented in a lot of textbooks. Okay, I want to talk about where this Pac-Man formula comes from. So let's plug in some different numbers. Pretend the radius now is 5 and the slant height is 6. So what's the circumference of the base here? So that is 10 pi. So because diameter times pi is my circumference, so 10 pi. And then the next question is, what's the length of the edge of the Pac-Man? So that means along the edge here, what's that length? Well, it has to be the same. These two things have to fold up. So whatever this is here, this has to meet it exactly in order for this thing to fold up into a cone. So it's the same. It's 10 pi. If the Pac-Man was a full circle, so imagine the same thing, but it's a full circle. Okay, this is not meaning I fold it up. It just means what would be the circumference of that full circle? Well, the circumference of the full circle would be whatever the radius is times 2, the diameter, times pi. So it's 12 pi because our slant height is 6. Our radius or slant height for that circle is 6. So that would be 12 pi. I'm going somewhere with this. So the question is, what fraction of the full circle is the Pac-Man we see? Well, the amount that we have is 10 pi. We know the full circle should be 12 pi, so our fraction is 10 pi over 12 pi. That's the fraction of the circle that we're looking at here, is 10 pi over 12 pi. So write out the fraction of the circle times the area of the full circle, the mouth closed. So our mouth closed, once again, would be 36 pi if it was a full circle, but it's a fraction of that, and we know what fraction it is. It's 10 pi over 12 pi. So 10 pi over 12 pi times 36 pi is the area of the Pac-Man, or if you think about that, what we had was 2r pi, that was our original r. We had 2l pi, that was our l. We happen to use 5 and 6 for our numbers, but it works out the same, so that works out to pi rl. And that is whatever that is. Those cancel. It's 10/12, 36 pi. But that's where that comes from, is no matter what numbers I plug in there, I'll have some canceling going on. Pi's will cancel out, 2's will cancel out, the L and the L squared will cancel out to just an L, and it will always be pi r L, because it's essentially like we've calculated the fraction of the circle that we're talking about. We know the radius of the circle we're talking about. We call that the slant height, and we'll always end up that number. I just want to know where that came from. Okay, spheres.